So I wrote down here, naming acids, and then I put in brackets, remember your flow chart. And then I said, hey, let's get that chart out. I stuck the flow chart on the back of the yellow sheet. Flip the yellow sheet over. This is how to name almost anything. So, quick review, some basics. How can you identify that something is an acid? Well, there's a fairly, I can't call it easy way, but it works most of the time. So, many compounds, such as HCl, which is hydrogen chloride, take on acid properties only when mixed with water. That's why you may have noticed everything we played with last on the lab was a liquid. For this reason, acids are often shown as being dissolved in water when the formula is written. So this, Amber, you will need to know. If you see HCl, that's not necessarily an acid. But if it's dissolved in water, we write it as HCl aqueous, where AQ refers to aqueous or dissolved in water. So you will need to recognize that when you see it. If you see HCl and in brackets AQ, stands for aqueous, you can remember that like aqua, it's where the word aqua comes from. It's dissolved in water to make a solution. Acids are written with hydrogen first. In other words, Emily, if I say to you, is this an acid? First thing you'll check is, does it start with hydrogen? It may not be, but I'm telling you right now, if it doesn't start with hydrogen, it almost certainly won't be, except for one exception. Okay? So acids are written with hydrogen first, unless, for what it's worth, it contains a carbon, in which case the hydrogen H is written last, such as the acid in vinegar is this, CH3COOH. CH3COOH. Why don't they combine the O's and the H's, Mr. Duke? Because they don't. Sometimes you'll see it written with the H in front. I like this better because then my rule of an acid beginning with a hydrogen makes way more sense. So sometimes you'll see it written as, well, I also gave you folks a pink sheet. Yes, a periodic table of the elements. And on the back of that pink sheet, there was the polyatomic ions. Also on the back of that pink sheet is a list of the acids, the most common ones. So if you want to take a couple of seconds, see if you can find that pink periodic table of the elements sheets and get that out. That would be a big help. I was going to do a big, long song and dance about how we name these things. I talked to Mr. Perugia yesterday, and he actually says for the provincial, you don't need to know the naming process, which is good because it makes no sense. It's purely memorize the stupid names, and I didn't like it. So all of you right now can go, try again, Mr. Duke. You can go yoink, like that. Not like that, Mr. Duke. And you can go yoink, like that. And you can go yoink, like that. And you can turn the page.
You think they'd be more excited about it?
They're after lunch. They're zoned right now. And I was going to have a bunch of questions here on naming the acids. We're going to go yoink, like that. And instead, what you need to make a little note here is this. You need to know the acids on the pink sheet. So I'll probably continue that, Amy, for the remainder of the year. If I put it on color photocopy paper, that means you're allowed to bring that one out for a test. It probably means it's important and a reference sheet. There'll be colors so you can find them easier. So the big four acids are what? Hydrochloric acid. Does anybody know where hydrochloric acid is in you? It's a stomach acid. Okay? Your stomach, very strong acid. Enough that if we somehow got it out, it would burn you. Sulfuric acid, they use that, I think, in batteries, car batteries. Nitric acid and acetic acid. Acetic acid is in vinegar and some other foods. So the homework was going to be an acid naming worksheet. Hey, it's not going to be an acid naming worksheet. Woohoo! The rules for naming acids are strange and bizarre, and I'm glad we don't have to memorize them. I might teach them next year just for the nerdiness of it, but for what it's worth, ick and ate became us. No, anyway, you had to memorize them. Naming bases. Now, what are bases? Those are the opposites of acids. That was a little bit easier. First of all, do you remember how can you spot an acid? What did they almost always begin with? Hydrogen, H. How can you spot a base? Well, a base is written almost always with an OH at the end. Almost always with an OH at the end. I can't say always because the problem is vinegar, which on your pink sheet is written as HCHCOO, is sometimes written as CHCOOH with an OH on the end, which is why I said some of these rules are kind of dumb. But aside from that one, you can be fairly sure that if it ends in an OH, it's a base. What is OH? That's also on the back of your pink sheet. It's a polyatomic ion. Hydroxide. Hydroxide. In fact, it's the compound, the polyatomic ion hydroxide, that makes things into bases, for the basic ones. No pun intended. Otherwise, the naming is the same as before. We use the IDE rule. So, for example, NaOH is, what would I call that? What's Na? Sodium. What's OH? You would call this sodium hydroxide. If you look at your yellow sheet where you have all those pHs and bases and things, what's very, very basic? Household cleaners. Soap, mildly basic, but it cleans our hands very, very well. One up from soap is bleach. Bleach will probably not be that good for your hands. It'll take color out of clothing. Ammonia. Ammonia, if you get it on your hands, isn't going to burn your skin. What's ammonia? What do we use that in? Do you guys know? Which household cleaner? How many of you ever used Windex before? Okay, that smell is ammonia. Okay, that holy smokes, that, wow, that goes right into the back of your head smell. That's ammonia. Your nose doesn't like it. Okay, one up from ammonia is bleach. Bleach you don't want to get on your hands. I mean, if you get it on your hands, wash it off, you'll be fine. But you might even have a slightly lighter skin if it stays on there for a while. Oven cleaner, very basic. We have a fancy schmancy name for objects that are very, very basic, begins with the letter C. We say that highly reactive bases are called caustic. Caustic. And by the way, I fibbed to you a little bit. I said the pH scale goes from 0 to 14. Nerd that I was on the long weekend, I was Googling what is the most acidic substance ever made. There is actually something that is 10 to the negative 35, way over to the left of 0. It's so acidic that you can only store it in a special Teflon container. It'll burn through glass like nothing. It was made in a chemical laboratory about 20 years ago. Kind of nerdily cool. So naming bases, no problem. You do have to recognize an acid and recognize what's likely a base. How can you recognize that it's probably an acid? What letters to begin with? What letters to begin with if it's an acid? H in all likelihood, except for the one weird one, vinegar. How can you recognize a base? What letters does it end with? It ends with a hydroxide. Next page. So, acids and bases are chemical opposites. It's sort of like black and white. They're chemical opposites. Acids have a whole bunch of hydrogen ions, H pluses. Now remember from your periodic table, how many protons does hydrogen have? 1. How many electrons does hydrogen normally have? 1. If it's an ion, it's lost that electron. And so when I write H plus, really what I'm saying is it's a proton. Acids have lots of extra protons kicking around. And those protons, they want to get involved with other electrons. That's why they burn your skin. Okay? Bases have a whole bunch of OH negative, hydroxide negative ions kicking around. If you take OH negatives, hydroxides, and H positives, protons, and you mix them together, they combine. These react to make, what do you think, what would you get if you combined an H? First of all, I have, in terms of the crisscross rule, I have one positive and one negative, so they crisscross quite nicely. You would get HOH, but we don't write it as HOH. Anybody see how we would write that? I heard it. Yeah. H2O. Acids and bases combine when they neutralize each other to give you water. These react to make H2O. And what that means is, because we said acids and bases start off dissolved in water, if you were combining an acid with a base, you can't have both something that's both acidic and basic at the same time. Oscar, they always cancel each other out. Okay? So a solution can't have, it can't be both acid and basic. It's one or the other, or neutral. Okay? Oh, can't have both of both. That's probably not the word I want to put there. What do I want to put there? High amounts. Sorry. High amounts of both. When mixed, they neutralize each other. So you can have something, don't write this down, you can have something that's really acidic, but as you add more basic to it, it gets neutralized and it gets closer to here. As you add more basic to it, it gets more and more basic until eventually you're mostly basic. You still might have a few H plus ions floating around in your solution, but not very many. And that's what that little picture is trying to illustrate to you. It's either acid or basic or neutral. What you're really saying is you have a lovely tie. In fact, when H plus ions and OH ions combine, they form water. The chemical reaction is H plus OH negative gives you H2O, and the crisscross rule says that's even a balanced equation. What does that mean? pH is really a measure of the excess H plus, the excess protons in a solution. A pH of 1 has lots of extra protons, lots of extra hydrogen ions, lots of extra H pluses. A pH of 12, doesn't have many at all. Probably still has a few, but there's not many. So a pH of 1 has more H plus than a solution. Can you give me a pH that would have fewer hydrogen ions than a pH of 1, that would be less acidic than a pH of 1? pH what? What number? 2 or 3 or 4. And it's kind of counterintuitive because people say if it's less acidic, shouldn't it be smaller than 1? No. On the chart, which is why I gave you that chart, more acidic is closer to 0. Less acidic is going to be a bigger number. So yeah, sure, a pH 3, let's say. If you have a solution that has pH 9, that has very little hydrogen ions kicking around, very little extra protons kicking around, but it has lots and lots of OH negative ions kicking around, extras. What's the charge on those OHs? Negative. They also want to react and bond with stuff, which is also why as soon as you get to a pH of 13 or 14, that will also burn your skin, because they're negative. They're going to be trying to get protons off of you, doing damage. So a solution of pH 10 would have even more OH negative ions. Remember, concentration of H plus is the number of, come on, pen. Hydrogen ions in a defined volume. So we talked about the concentration. We're saying how many you got per liter. More concentrated, you got more hydrogen ions kicking around in that liter. Less concentrated, you got less hydrogen ions kicking around in that liter. And another new word, the word solution. That's a liquid with something dissolved in it. So what you were dealing with during your lab was various solutions. Justice, can you read to me what I wrote here in the little stars? It says, see the what?
See the chart on page 229.
You know what? If we were clever, we would open our textbooks to page 229 right now. If we were clever. It's table 5.6. There is a lovely chart that has the properties of acids and bases. So, taste. Now, please, we are not going to ever taste these. They have been tasted by experts, but for what it's worth, acids taste sour. Lemons, limes, vinegar, common examples. Bases taste bitter. Soap, for example, doesn't taste very good. The quinine in tonic water is one example. I've never had tonic water, so I wouldn't know. Touch. Acids will burn your skin. Sulfuric acid, which is battery acid, is one such example. Bases feel slippery. Soap being a great example. Many bases will also burn your skin. For example, sodium hydroxide, which is called lye, is one example as well. Indicator tests. Acids turn blue litmus paper red. Phenolphthalein is colorless in an acidic solution. Bases turn red litmus paper blue. Listen closely. Bases turn red litmus paper blue. Bases turn red litmus paper blue. If I was a good teacher, I'd come up with a dumb way for you to be able to remember that bases turn red litmus paper blue. I got nothing. Maybe you came up with something there. I don't know. Phenolphthalein is colorless in slightly basic solutions and pink in moderate to strong basic solutions. Acids corrode metals. Do you remember we dropped some zinc in the various solutions? The ones that bubbled, that fizzed, were acid. The ones that did not were basic. For what it's worth, we didn't practice this, we didn't test this, but both acids and bases, if you dissolve them in water, they'll conduct electricity, which is why, for example, we use sulfuric acid as a battery in car batteries. pH, acid less than 7, pH basic more than 7. Production of ions, acids form hydrogen H plus ions when dissolved in a solution like water. Bases form hydroxide or OH negative ions when dissolved in a solution. There is your acids and bases summary. What's your homework? I got two things. First of all, if you turn to page 233 in your textbook, questions I'd like you to answer. We're going to correct this, Mr. Duick. I wrote page 233, numbers 2 to 15, but I just told you I was going to cancel off the naming. So you can go scribble, 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 and it's going to be numbers 2 to 12. And then I wrote here, use tables 5.2 to 5.6 to answer a lot of those questions. So in your textbook, there's various tables. 5.6 is the one that we just finished looking at. If you turn back, there's a 5.5, a 5.4. So before you ask me, check those tables out. They're going to be asking you things like, hey, which acid is used in such and such? They're in the charts. And also, we have for you a worksheet called Acids and Bases. Let me hand that out. Pause. On the worksheet that's called Acids and Bases, you can skip number 11 and 12 on the back. I did attach the answers. Okay? So if you go through questions 2 to 12 from the textbook, now numbers 2 to 12, the answers are not in the back, I don't think. Hang on to that. Don't hand the textbook assignment in. We'll go over the answers later on in class or first thing on Friday. The worksheet, if you finish that in class, you can certainly hand it in because that has the answers. You can check your own answers. So folks, this is your chance to get caught up.